Hello everyone, welcome to the Well of Curiosity and what will be a brand new series for this channel. I've decided to call it Your Universe, and it's going to be based around the topics and the questions that you find the most interesting. You can submit questions at any time, either here on the channel or over on Facebook, and I'll try and turn as many of them as possible into videos. Now, the question we're going to start with was submitted to me a few days ago and is absolutely immense. It's going to take us on quite a journey, so do prepare yourselves. The question is, how did the Milky Way come into existence? Starting easy, I see. Well, to answer this, we have to go right the way back in time to the start of the universe. Over 13 billion years ago, everything in the universe, all matter, was packed into the same tiny space. Now, for reasons we're still trying to understand, we believe the universe started to expand very, very quickly, and it became filled with this incredibly hot, dense soup of subatomic particles, positive protons, negative electrons, and neutral neutrons. Now, as time went by, that soup started to cool down. The particles began to move a lot more slowly, and they were able to move near to each other to team up to form the first atoms. Now, for a moment, just imagine that in your left hand you are holding a single grain of sand. Now, that grain is going to be very, very small, but you can still just about see it. Now, in your right hand, imagine that you're holding something that is 100,000 times smaller than the grain of sand. It's so small you can't even see it. That is an atom, the basic building block of the universe. Have a look around you. Everything you can see is made of atoms, including you. Now, let's go back to the early universe. More and more atoms were forming, huge clouds were building up, and they were mainly made of the same thing, hydrogen, the simplest atom with just one proton and one electron. And there was also a little bit of the second simplest atom, helium, mixed in there as well. Now, as more time went by, as more atoms built up, a force took over, the force of gravity. Now, gravity is that invisible force of attraction that can pull objects together. And gravity can come from anything that has mass, anything that's made of stuff. That could be a planet, a star, or an atom. Even atoms, tiny as they might be, they all have a small amount of gravity. So gravity started to draw the hydrogen together, and they formed the first stars. Now, these stars were much bigger than modern day stars. They were over 1,000 times the size of our sun. And our sun is no slouch. You could pack over 1 million planet Earths into our sun. So you can imagine how big these first stars would have been. These huge stars had an enormous amount of gravity, and pretty soon they started to move towards each other to form huge clusters of stars. And then soon after that, some of those clusters started to move towards other clusters, and they started to swirl around the same point in space. This was the birth of our Milky Way galaxy. Now, as more and more stars were added into our galaxy, it started to spin faster and faster and faster, until it got squashed into the huge swirling disc shape we think it is today. Now, this sort of thing was happening in a lot of different places. We started to get loads of galaxies forming. We think there are over 2 trillion different galaxies that we've discovered so far. There may be more out there. Most of them are the same swirling shape as our Milky Way, but others are completely different. Now, we've been watching these galaxies as they move through space. Sometimes they'll move away from each other, other times they'll move towards each other, and some galaxies will even crash into each other, absorbing each other to form even bigger galaxies. And this is what we think our Milky Way has done. In the past, it has absorbed other galaxies into itself, making it even bigger. Now, it's not just stars in our Milky Way galaxy. There are all sorts of objects in space. Planets, moons, asteroids, comets. Well, let's go back to those very first stars. Very big, very bright, and made up of hydrogen. Hydrogen is the fuel that keeps a star burning. In the heart of stars, it is incredibly hot. Those atoms of hydrogen have plenty of energy. They're whizzing around all over the place. And a lot of the time they're crashing into each other. And when they crash into each other, they fuse together and they form helium. Now, as they fuse together, they release energy. That energy travels away from the star, and that is what we see as starlight. This process of fusing atoms together is called nuclear fusion. Now, this process will keep on going until all the hydrogen is used up in the heart of a star. Now, in a very big hot star, that doesn't take very long. But then the helium that gets made starts to get squeezed and fused into new elements. And then those new elements can get fused to make even more new elements. So things like oxygen, carbon, nitrogen, lots of things that we have around us were born in the heart of a star. And this process keeps on going until iron is made. Now, iron doesn't fuse very easily at all. So once a star starts to develop iron in its heart, it starts to collapse. And eventually, most of the star blows apart in a wonderful explosion called a supernova. Now, the force of that explosion is actually so great that you can get, in just those few seconds, enough energy to form rare things like gold. And in that explosion as well, all of the things that the star has made get flung out into space, and then eventually gravity may draw them together in the future to make planets, moons, asteroids, comets, and even more. Now, not everything happened billions of years ago in the past. Things are still going on right now. New objects are getting made and old ones are probably blowing themselves to bits. There are over 200 billion stars across the Milky Way, but there are still huge clouds of gas that are able to come together, and we get new stars forming in our galaxy every single year. So hopefully I've managed to provide some sort of an answer to what was a pretty incredible question. If you have enjoyed it, then please like, share, subscribe to the channel if you're new. And instead, if you have enjoyed it, check out the other content on the channel and over on Facebook as well. And I hope to see you all next time.